Cool. So this week we're going to go through part 2 of Mongo. Last week we learned some basic CRUD design of Mongo. We learned how to connect using Mongoose. We learned how to create a schema and a model using Mongoose. And then we learned how to query the data and to create new documents for our collections. Kind of just an overview of it. Remember, Mongo is our database. Mongo is the database server. Within that server, we can have multiple databases. On that database, we will have what are called collections. And collections will be collections of documents. And each document will be, if we use Mongoose and we use our schema, will be modeled after that schema and after that model in Mongoose. So we'll have these collections of data. And last week, we were really concerned with, one collection of data and the data that we can put in it. This week, we're going to start expanding our horizons a little bit and talk about documents and collections that reference other documents and collections. And it can go back and forth, and we'll go over a lot of that today. And what we call a relationship. Before we get started with that, I'm going to show you a little bit how to import data. This is probably not going to be something you do very often. When you are in the professional world, the people that are importing the data are usually the database administrators. And as a developer, this isn't really going to be a big task of yours. Although today, and with this project we're working on this week, you will need to import the data, so I just wanted to show you how to do it. So, share my screen. So I'm just throwing it into our mini from last week. You're not going to be doing this. The mini is over last week. You're going to jump straight into your project tonight. I'm just throwing it in here just to give us an idea of what we are doing. Let me open Compass. I'm going to connect with our database or our Mongo server if it's connectable. Let me see. I might not have it running. Oh, okay. It's running. And we'll see all the database we have in here, right? We have the Bear database from last week. We have the Bear DB from last week with all of our bears in it, etc. We have friends from last week. We have a single friend in there. Oop, did I have it as bears? Oh, that's funny. No, where's friends? Friends, okay, there we go. Friends, and we have a single friend in there, me. Yeah, so Compass, remember, we can use this. You can use the Mongo shell if you feel more comfortable using a command line interface like the shell. You can use Robo3T if that's what you're comfortable with. I like Compass a lot, so we're going to use Compass today. So what I've done here is I've brought in this folder of data. Okay, we have quite a bit of data in here, and all this data has actually been exported from a Mongo database. And it's in Mongo format. We have our object ID. We have a lot of special Mongo keys in here. And so we have a bunch of data in here that I want to import. Okay, my characters is 82 lines long. All right, a lot of data in here. So I'm going to show you how to import. And actually, let me move this over so I can see any questions. Sorry. So I'm going to show you how to import some data. I'm just going to open our little VS Code terminal here. And so when you install Mongo, And if you have Mongo running, we have Mongo there. It also has, cool. So you should exit out of Mongo and not Control-C. One little word of warning there. So if you have installed Mongo, you have also installed something called Mongo import. And Mongo import is going to take a few pieces of data, and it's going to import these special Mongo JSON strings for us into it. So if you recognize this data, this is coming from the Star Wars database, which we have worked with extensively. Star Wars APIs. This is all data from the Star Wars database, which is an open source API that allows us to download their data and use it as we want. So what we want to do is we want to create a database called Star Wars, right? And if we look into our Mongo Compass, we don't have anything called Star Wars database, right? How do we create a database? How can we create a database using Mongo? Anyone? How do you mean, Alex? Use DB name. Yeah, totally. We can do that. And actually, that's not going to create a database for us. So if we go in and say, use the name of the database, it won't actually create it for us until we do one specific thing. Post, write, make a collection, insert a document into it, right? If we use it, it'll use it, but it's not going to save a database on our system until we save some data in it. So we post a document in it until we, include something in there. What this Mongo import does is it'll create it automatically for us just because we're going to save some data into it. So what we do is we give it a double hyphen and we just say DB and we give it the name of the database that we want to call it. I'm going to call it Star Wars. Okay. So now that we have it going to a specific database on our currently running Mongo server, we need to also create a collection. It's really simple. Call it collection. Double hyphen collection, and then immediately after the collection, we're going to give it the name of the collection we want to save it to. So let's just go with characters because it's the first one we got right here. So we're going to call it characters. And now that we have a database, we have a collection to save this data to, we want to give it the path of a file that we are saving to it, right? And so we're just going to call that characters. Oh, nope, sorry. I needed to CD into that data folder. So you see that all of our data is in the data folder. I'll need a CD into it. Blah, 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 CD data. LS, there we go. We got them all. All right, so we're going to go Mongo import, DB, Star Wars, collection, characters. File is going to be characters.json. Okay? And so hit enter, connect to localhost, imported 82 documents. Cool. So we didn't have a Star Wars database before, and we have one now. All right? We have a characters collection in here, and we have 82 documents in here from our collection. Okay? It is very handy dandy. So if you can get your hands on some Mongo data, data that's in a specifically parsed Mongo JSON file, you can import it wherever you want. You can also export the data from your Mongo database into those files and kind of save them or share them or whatever you want to do with it. One other thing I'll show you about this, how to import and using Compass, is that Compass also has an import tool. So we're going to call this Films. Let's create the collection. Let's come in here into Films and where is it? Collection, import data. So we're going to do import. Input file type is JSON. We can go in and open that up, and we can just import it like that. And it'll import it for us as well. Either one of those ways will work, but you do need to import each file separately, okay? So you're going to need to create a characters collection, a films collection, a planets collection, species, starships, vehicles, etc., right? Let's go, I want to do that, starships. While we're here, cool. And now we can go in and look and see we have a starships collection as well. Any questions right now about importing data or importing these files? Because you will be given some files today, and you're going to need to import them yourself.
Yeah, I have a question. How did you get your Star Wars files on your Visual Studio? Did you clone that, or?
So I downloaded this specific set, and I can give it to you as well to practice with. One moment.
So I guess my question is, are we downloading like a data set and then uploading it to that folder and then connecting it to Mongo?
You will be given let's go. You will be given the data, and then you will need to import it to your database. I'm not sure if the Star Wars data is the data that you need this evening. I'll look into it, but you'll have the data no matter what. For Lisa, how do we quit Mongo? I've always seen Control-C. Control-C is kind of the general kill for any terminal app running. Kill on Mongo works for sure. The correct way to exit out of Mongo is to type exit. So if we have Mongo running, right, it's going, we can show DBs, etc., etc. If you type exit, it will gracefully shut down your connection, and it'll even tell you goodbye. All right. Alex said kill on Mongo. That totally works, and that works for any app whatsoever running. And that's going to brute force close every instance of that app running. Okay. So the proper way is supposed to be exit. Also, Mongo is the nicest database to exit from. If you ever use any other databases, there are a complicated series of commands that you need to give it in order to properly exit from it. But whatever gets you out of there. If you just Control-C without doing the kill all, you may have an instance running on your computer without knowing about it. So try to exit as much as you can. Any other questions? All right. So let's get into the heart of the matter tonight, which is something that we call relations within our data. Let me. I want to draw for you. I know how much you love the drawing. So. So lately we've been working with, as we know, just a regular collection with some data in it, and that data, those documents contain data about that one specific item, right? It is this all self-encompassing piece of data. It's a document, and that's all we need to know about it, right? So we have, in our bear database. In our bear database, we have bears. And those bears, we know what we had: a species, a Latin name, created on, created at, updated at, right? There's no need to reference any other data. This is all we need in here. But it's going to come to a point, more specifically tonight, where we're going to have data that references other data. And we need to know how to model that and correctly, and how to write it in our schemas. So let's go look through our Star Wars database real quick on here. We are going to see, that we have a characters collection. Each document in that characters collection is going to have an ID, edited, a name, gender, skin color, hair color, height, eye color, birth year, key. And we'll go over key in just a minute and what that is. Homeworld key and homeworld. And we'll see on homeworld that the homeworld is an object ID just like our ID, right? And so what this is doing is this is referencing another document in our database. And we've given the ID for that specific document. And so we know that these IDs are all going to be unique, even across collections. I don't want to change that. But let's go, kind of hard. If we had a world, if we had our planets on there, let's do that. Let's add our planets. Create collection, planets. Oh, not in the bears. Okay, I'm going to planets. We're going to go collection, import data, import our planets. Cool. So we have our planets now, all right? So let's come back here and let's see Darth Vader. Does anyone know what planet Darth Vader is from? Off the top of your head? I'm curious. Yeah? All right. I didn't know that.
Tatooine.
We got a bunch of winners. I didn't know he was from Tatooine. All right. Let's see.
That's because we've actually watched the prequels.
I watched the first two. I didn't watch the third. But so let's go ID. And then we're going to have to call this object ID in order to look it up. And we'll give it the ID, and we are going to find it. And you are all very correct that Tatooine is the home planet of Darth Vader. Okay? So now we have a reference to this one document, referencing it from the character, right? Before we go any further, I want to talk about some very specific ideas when it comes to relations between two data types. It's a concept that is not just a Mongo concept, but a concept that is not all database, but very much Mongo, and any kind of relational database that you would work in with SQL. Stephanie, you're right on the mark. It's just like primary keys and foreign keys. if you've ever worked in a SQL database or a relational database. So in Mongo, we can still, it's a document. It's technically a NoSQL database, but it doesn't mean we can't have relations between our data. And so let's come in here. I want a little bit of, I just want to talk about the types of relations we can have, okay? The first relation that we can have is called a one-to-one relation. And a one-to-one relation is going to be, and we're going to talk about more than one document right now, right, for the rest of the class. So we're not going to just talk about a single document until we get to embedding data. But a one-to-one is one piece of data references one other piece of data, and that one other piece of data references it back. So think of something like one user to one user profile. Okay. Think about one patient to one medical record. Right? There's only going to be one medical record per patient, and there's only going to be one patient on that medical record. Okay, so it's always going to be a one-to-one relationship. And I want to call this, I think this is called relations, is the correct. So one-to-one relationship is one piece of data references the other piece of data and vice versa. Okay. Anyone think of any other one-to-one relationships that we could give as an example? Anyone? Think about one thing that it references the other thing, and there can only be one patient on one medical record and one medical record per patient, right? Username and password? In the way that a user would always have one username and password, and one username and password would reference one user. Yeah, that would work. Social security number? Absolutely, right? So you have one US citizen to one social security number, hopefully. Where as a US citizen, you have a social security number and it's yours, and that's the only one you have, and the social security number only points back to one citizen. Absolutely, that's a fantastic analogy. Driver's licenses, things like that, right? Where you only have one driver's license and one driver's license only goes back to you. I don't know, what's an ETH address? One human to one dental record. Absolutely, one human to one fingerprint, right? We could name tons of one-to-one relationships. Oh, Ethereum? Yeah. That's yours, and it only points to you. One hash ID to one document? Yep. Mongo itself does this, right? Absolutely. So we have a single document with a single ID, and it references it back and forth. User account to user email. Yeah, if we have a configuration on our server that only allows one account per email, and emails have to be unique, then yeah, absolutely, one user account per email and one email per account. Awesome. So that's a one-to-one relationship. We can sit here and think of examples all night, right? Because this is a lot of stuff that we have in our everyday lives. The second is called a one-to-many relationship. On a one-to-many relationship is going to be one document that has many relations inside of it. So think of like a online shop order, right? So one order is many items. Probably could be one, could be many. It doesn't have to be one or many, but it is a one-to-many, right? So there's one order per many items. There's many items on one order, all right? Think of movies. So we'll think of one film many actors. Okay. Slash actresses. So one film is going to have many actors and actresses in it, right? So that's one to many, and actually that's more. I think that's more on the next one. Let's go one city to many citizens or residents. Right, so you have one city and you have many residents inside of it. Anyone have any other one-to-many examples that you can think of? One student, many grades, or many classes which have many grades? Absolutely. That's great. One instructor to many students. Yep. There's many students, or like one class to many students. Maybe not one instructor, because think about me. You've had multiple instructors in this one class, but we've all been in this one class, right? So many students. A family tree. So I guess in that case, it would be, the farthest down you can go on the family tree. There's one person and it branches off into many. Many instructors, there's only one, Dan. Thanks, Victor. Yeah, those are all great examples. I like the class. One class, many students, one student, many classes / grades. Great. So we have this one-to-many. We also, in a kind of a subset of one-to-many, we can think of something called one-to-few, where few is really more of a subjective kind of idea of what you think a few is. And we want to, as we build database collections, we would like to map one to few as much as possible. Think of if you have one to many, if you have one city to many residents, and you are searching the entire list of all of the residents of New York City for one resident, it's going to take a long time to search iteratively through that unless you had an index and all this crazy stuff. But if you had, say, instead of New York, let's do NYC to all NYC residents. Instead of you having NYC to all NYC residents, what if we had NYC to all NYC? I don't know how to spell boroughs, so I'm going to just go for it. All NYC boroughs. So there's 5 boroughs in New York, right? And then if we had one borough to all borough residents, right? So now we've kind of broken that off into these little subgroups, and then we can go by street name or etc., right? As long as we knew what borough the residents lived in and what boroughs were in New York City, right? Another one to few would be something like, think of a textbook, right? One book can have few authors, right? There can be a number of authors that worked on a single textbook, but there's not going to be a million authors that worked on one textbook, right? There'll at most probably be 10, probably less than that, 4, 3, 4, etc. So this is a relationship called one to few, and this isn't really an official relationship in this. This is kind of a subset of one to many. All right, so when we talk about databases, we talk about one-to-one, one-to-many, and what's our last one? Many-to-many, absolutely. Many-to-many, right? And so many-to-many, sorry, I'm weird. Is going to be this. Is going to be more in line with the films and actors one, right? So we have one film has many actors, and one actor has probably been in many films, right? So we have this like dual relationship where, you know, one actor has been in many films, but one film has many actors. So this is a many-to-many relationship. We can think of it in kind of a server way as one user or two many roles. So say, you know, you're the administrator for your server, but you have roles within your server. You're also a regular user. You're also a manager. You're also an administrator. And one role has many users. This is a little bit more difficult to think about in a kind of to just really visualize this one-to-many. I think the one film to many actors and one actor to many films is a great way to think about it. One-to-many, by the way, is probably the most common type that we'll have, right? We will have a user that has a hometown, right, or that home planet. And you're only one user to, there's only one home planet per user, but that home planet's going to have many users on it, right? And so the one-to-many is probably the most commonly used. One-to-one is used, and many-to-many is used fairly commonly as well. But one-to-many is definitely the most commonly used. Are there any questions on this? Or does anyone have another a many-to-many example that would work well? I always like more examples or ideas. Facebook friends, absolutely. So we have a one person has many FB friends or just regular friends, right? And I guess that just goes back again, right? One friend, I guess they're all friends. One person to many Facebook friends, and each of those friends has their own friends, and that's a many relationship as well. And Facebook actually uses something called a graph database, which we learned about graphs many moons ago, but that's what Facebook uses. It's actually a graph database because it links them all together. And it is a many-to-many. No moon. So, yeah, that's a great example. Definitely a many-to-many relationship. Any other questions right now? All right. Before we get started with the real meat and potatoes of this lecture tonight, I want to take a break. We'll do a 5-minute break. We'll be back at 45 after, and then we'll get started with actually writing our schemas out and mapping our models to create these relationships with each other. Okay? Okay. So now that we kind of have an idea of the relations our data can have with each other, we can go about building our models. And it's important to think about the models or the relations between the models when we build them, right? We just saw that example of, we can have one city to many residents, but what if we had one city to one borough and one borough to many the residents? That just, divides our search time and cuts it in a fifth, right? And so when we go through and we see, when we're building a relationship between the data, we'd like to see what kind of relationship we need to build into it. So let's look at the starships data. There's one on here. Cool. So this starship, Starfighter, has a pilot's array on it, right? So there's one. There is one starship to possibly many pilots. In this case, it's one. In this case, it's three. And we want to know about the pilots on the starship. When we go into characters, let me just do this. Seems that they have not deemed it important to list the starships that this character can fly or has flown. It was important for them to understand in the starships model which characters have flown it or can fly it, right? The same is for planets, right? We don't need to know which characters are from this planet, right? This is a one-to-many relationship. No, I gave it away. This is a one-to-many relationship. We have one planet for multiple characters. So the only place we really need to understand what planet that character is from is on the character itself. We could go in there and give it this big, huge, long list of characters that are from that planet, but we're going to show you, well, you already know how to find a collection of characters or a collection of IDs, right, that contain a certain ID. Collection of documents that contain a certain ID, right? So we can query by the home world if we know the home world, and we can find out where characters are from. And you will need to do that tonight because the characters aren't going to have a list of the films they were in, but you'll need to find every film that that character was in, etc. But just talking about modeling our data after these relationships. Let's go back to the starships. Let's cancel that. And we'll see that we have one starship to many characters. And it could be many characters to many starship, or one character to many starships, but we're not super interested in that bit of data. If you were, then you would model that as well as a many-to-many relationship. But in this case, we're going to model this as a one-to-many relationship. All right. So let's go into our. Let's go. We'll save that. Let's come in here and see that we have a bears with a controller and our schema in bears. Let's do something similar for starships. Let's go File, Starships, and this is all. I said File, I meant Folder. This is all up to you as well, how you're going to map your deal with your file structure. So we're going to go, we called it, in bears we called it bear.js. We're just going to call it starship.js. So we can call it starship model as well, since that's what we're doing is we're building a model, right? So let's build this schema out, okay? We want to, it's the first thing we want to do when we're building a schema. We'll bring in Mongo-II. Thank you. Both of you. Okay. Bring in Mongo-II. We're going to call it Starship Schema. We're going to create a new schema out of it. And then we are going to export module exports. And what are we going to export? We'll export the model itself, right? Exactly. And we're going to give it the name. We're going to call the model Starship. And we're going to pass the Starship schema to it. Remember that it does take a third property in here if you want to call the collection something other than lowercase starships, which is what Mongo-II will automatically call it. It'll take the name of your model, it'll lowercase the first letter, and it'll add an S to the end of it. Or it will pluralize the word. It might not always just going to add an S. It might add an ES to it. But if you want to give it a name, we can call it Starship Collection, etc. We can give it any name we want right here. But Starship will still be the name of the model. But if we don't, it'll create our collection for us. Let's look at what our Starship has in it. It has a Starship class, has a hyperdrive rating, it has something called a key. And so I'll just explain to you what this key is before we go any further. Whatever database was, whatever the Star Wars API database is, it doesn't use Mongo. Okay, so we have kind of scraped all the data from the database, and we have mapped all of it has these internal keys, and it looks like they are sequential keys, so it's probably a relational database that they've just given a sequential key to. So that's the ID on their database. We've actually mapped it to use, so we can see we have pilot keys. That would be the key of the pilots. We've mapped it to use Mongo, so that's why we just use the pilots. So we don't have to worry about the key itself. We could, but really we're worried about Starship class and the hyperdrive rating, right? So let's go in and create our definitions. Starship class, hyperdrive rating. All right, our Starship class is going to be the type of string. Let's make this required. What do we have? Okay. And let's do unique as well, because we only want one of each type in there. Hyperdrive rating will be a type of string. Not required. We want it required. Okay, so we've got the class and we've got the rating. We're going to pass that into our schema. It will create our schema for us and then create a model for us. So what are we going to do when we want to add a reference or a relation to another piece of data? Let's go in and we'll create characters. I'm going to come in here and just do a lot of copy pasting real quick for time's sake. We're going to call this model character. All right, and let's see our characters. We're just going to add a few of these in: name, gender, height. Let's just do that. So name is a type of a string. Required, we do want a name for every character. Is true. Unique, we only want one character per name. Gender is a string. Required, not true on that. Height is going to be type of number. Let's see. All right. Height is a number, and this number is in centimeters, just for you, so you know. So let's do, on height, let's do a min of 1. Because if you're less than 1 centimeter, I don't know, well, it might be less than 1. But we'll just do a min of 1, right? So this, when we load our server, should not have done that. We load our server, Mongo-II is going to go in and create models for every single one of our models that we've created, right? So if we've, in our server, if we import, we're going to call it character equals require and we'll come and do the same thing for starships. Okay, so as soon as we import these and require these, the character and the starships into here, Mongo-II is going to connect, and it's going to internally save the concept of every model that we've created, okay, and that has been imported to it. It's somewhere in Mongo-II, in the inner workings of the code, it has a reference to the names of these models and the schemas, and it's what makes Mongo-II really awesome. And so it now has access and reference to character and starship. Right? So it has reference to these models. So let's come in here and now create our pilots. So our pilots are going to be if I can find it. First of all, it's going to be an array. Our pilot's going to be an array, and it's going to contain object IDs that point to the different character objects. So how would we, I'll show you shorthand how to automatically tell Mongo-II that you're going to create an array. Just give it an array, okay? Give it an array, and within that array, we can now put our schema definition, right? So now it knows, Mongo-II knows that pilots is going to be equal to an array, and we're going to validate it against this schema definition. Are there any questions on that? Because that's kind of a little confusing in that all we're doing is telling Mongo-II whatever pilots is, make sure it's an array, and then whatever's inside of that array, make sure that it is equal to this. Because we are going to have a one-to-many relationship here. If we only had one pilot per starship, we could just do an object, right? But since we are going to have a one-to-many relationship, there are many pilots to this one starship, right? So one starship to many pilots. So we want to keep a collection, and the way we keep collections of data in JavaScript is with an array. Does that make sense? Cool. So yeah, obviously it's going to be an array, and it's going to have a bunch of object IDs in it, right? So I don't want you to think that it's going to be an array of objects, too. This object that we're putting inside of here is our schema definition. This is what the data that's being passed into this array is going to be validated against, okay? So just keep that in mind. So in here, we are going to give it a type, and we're going to give it what we call a reference, or a ref, okay? So the first thing we're going to do is type. And what is the type that we are including, what we want this to be? Anyone have a guess? The type is the model of the pilot, almost. That's the ref. We'll do that. But the type, what is the type? All right, let's look at what we have in here. So the type is actually going to be, and Caroline, you're really close, is actually going to be a mongoose or a Mongo type itself called object ID. Okay, object ID is a specific type to Mongo. And in order, we can't just type object ID here because we use string because that is a JavaScript class, right? String is, a number is, object, array, etc. Object ID isn't. So we need to grab a reference to object ID, and we can do that. Mongoose gives us I don't know why I said Mongoose. We're going to call it object ID. Okay, so Mongoose gives us that type for us to reference against. It is in mongoose.schema.types.objectID. And you can go, let's look and see what other types are in there. We have array, Boolean, buffer, date. You know, we have a lot of types in there, right? We're going to go with object ID. Okay, so now that we have a reference to a Mongo object ID, we can now add that as our type in there. Any guesses onto what our reference is going to be specifically? I know that Alex said the model of the pilot. Yep. But what is it going to be specifically? Guess. I'm like the exact thing we'll type in here. This is what I'm looking for. It's awesome typing. Not quite. It's gonna be the model of the pilot, like Alex said, and that character model is called character, right? That's what we've given it. We've called it. Remember, this is the name of the model. Remember, and so it's just called character. And we can just type that name of the model in there. Now, you might be thinking right now, like, how can we do that when we have not imported the character model into this file? And remember, when I just talked about as long as we're importing them into the server, Mongo takes these models and it remembers that this model is called character. And it remembers that this model is called starship. Okay? And when it references it in our schema, it's going to say, do I have a model called character in here? And you're like, oh yeah, I do. Okay. Does it have, is there an ID in the collection that matches the ID that was given to us? There is. Okay, then it's valid. It's a little abstract to think about because we haven't brought it in. There's no reference to character anywhere inside of this file. But just know that Mongo, or Mongoose, excuse me, is grabbing that. And it knows what that is. If we had, another one in here of planets, we can say, home planet is, let's do that. Home base planet. Let's just pretend like we have, nope, we don't want an array because we only have one. We'll pretend we have, let's just do this. Yeah. Yeah. Let's just pretend we have a model called planet. Okay. And so in here, we are going to say type of object ID. And we are going to say ref of planet. Okay. Say we had a planets folder in here that had a planets model, and we were bringing it into our server. Okay. And then we wanted to reference whatever home base it was in now. Okay. And so we have an object ID of our type, and the reference is going to be the planet model. Okay. Just say that's all theoretical right there. We actually have a character model. We can build a planet one if we wanted to right now. But that's what we're referencing now. See some typing. Yep, absolutely. As long as it's within the context of Mongoose and in a reference. So that right now, this reference is just a string. But Mongoose knows to go look for that string in its list of models that it's keeping track of. Okay. You still, if you want to use this model specifically, you still need to bring it in. If you are referencing it within the context of Mongo, you can just give it that string. And this is the only place that I'm not gonna say it's the only place that it happens. It's the only place I use it, right? Just know that that string in the ref references a specific model. Okay. More typing. Just to be clear on that, we could not do this. Okay? Because that would that would imply that we have an object called planet, and we haven't imported anything like that. We can do this, that's just a string, and Mongo-II knows to go look for that string in its list of models that it has. So the string and ref get the information, but just to confirm, we still need to have that top level reference. How do you mean top level reference? Oh yeah, you do. That's the only way that it's connecting, right? So you're connecting Mongo-II. If you didn't have this, then that file is not being loaded at all, right? When you start your server. This is the file that we load when we start our server. If this isn't here, say if this Starship isn't here, then that Starship model file doesn't get loaded on our server at all. It's just sitting there, unloaded. So we do need to load that in order for Mongo to know what we're talking about. Nope, not at all. It just, so how do I explain this? So let's want a little bit of, there we go. So let's say our server starts, yarn, not npm, yarn start, and yarn start runs node index.html or index.js. In our index.js file, this is the file that gets loaded. This is all Node knows about, right? This is index.js. Okay. Within index.js, we're going to load a couple of other files. And these are going to go point to other files, and they're going to get loaded onto our server as well, just because we've loaded them onto our index.js. Right? There could be entire folders full of files that are sitting on our server that never get loaded because they're not being loaded by index.js. Right? So this could be something on our server. It's on the server. Those files exist. They have really cool stuff in them. But if we don't reference them in this index.js, or maybe we'll reference one of them in here. So these ones aren't getting loaded. This one is, because it's being referenced. So it has to be referenced somewhere in a file that gets loaded. It does not have to be in the mongoose.connect file. It just has to be loaded on your server. Does that make sense? When we start our server, right? Let's go look into it. We are saying server.js. Okay. So let's go look at server.js. Server.js is loading Express. So that's bringing the Express project in. It's loading Helmet. It's bringing the Helmet project in and everything it's linking to. Cores, Mongoose. Now we can see character model. Let's go get rid of planet model. Character model. So it's going to go into character model, and it's going to load Mongoose again in here. Cool. It'll come back out. Go into Starship model. It'll load everything in here, Mongoose, and that's all it's loading. It'll connect. It goes through its whole thing, right? It didn't load planet model. So anything in here, we could have all kinds of stuff pointing to different things will never get loaded. So we just need to realize that we need to load those files on when we start our server. Does that make sense? Is that clear to everyone else? Does anyone have any questions on that? I just want to make sure that we understand why we even need to load these. And this could very well be in here if for some reason we wanted that, and it will get loaded, and we'll have access to Starship. We wouldn't have access to it on the on our routes, but we would have access to it. We would know about it. Does anyone have any questions about that? Import them. You need them. You need to import them in order to, and that's not something you'll have to worry about in this project. We've given you a lot of great boilerplate for it, but if for some reason you don't have access to it and you're wondering why you don't, it's because you're not importing it. You're not including it in your project, even though it's alive and well, living in the file structure on your server. If it's not on your server or not being brought in through some chain of command here, then it just doesn't exist. Cool, we have a couple other things to talk about. So, I want to talk about going back to one-to-one and one-to-many. So, when we're creating a one-to-many relation between our documents, we want to automatically start with a ref. We also call it linking. And we will learn this week as well how to get all the data from that ref without making another database call. But we want to start with a ref. We want to automatically just resort to linking to a different document, right? And same with many-to-many. We have many documents in it. The hard part about Mongo is it's really easy to create really bad relational data that is related to each other. It's really easy to. In one-to-one, and I'll show you how it's easy to do that, but I'll show you also how to not do that. As we want to start with embedding, or what we call a subdocument. And this could very well be the way to do a one-to-one is with embedding, but you can go either way. So let's go back into characters, and let's add something on here called address. Yeah, that's fine. Or we can do user info or something like that. We'll just do address. So we'll say that every character has their own address, right? There's one address that they live at, and every address only has one character. That is a one-to-one relationship. So this is some data in here that we want to include. Something like, we want to say street that they live on. We want to say town they live in. We want to say street address, zip code, all kinds of stuff on here, right? We could create a separate address model and reference that specific address model, but we know that every character is going to have one address and every address is only going to have one character. We have to decide which one is more. We don't have to decide, but let's think about deciding which one's more important. Which one do we want to search by? Do we always want to search by the address? We'd probably make that the model and the character part of the address. We want to search by the character and have the address as kind of a side thing that we have access to. I'd say, yeah, in this case, we care more about the character and themselves and their address is kind of a side thing. And so what we've done here is we have created an embedded document or a sub-document, okay? And we can give this its own types, right? So we can validate this just like we would any other schema. I'm just going to make everything a string today. This is a number. Okay. And so now our schema is going to go through and it's going to validate that all of these, that this is an object, first of all. So it knows that it's looking for an object for address, and then it's going to go into that object and validate all these things. All right. This is called a subdocument. Okay, and this is where we want to start with a one-to-one. Okay. Where do you think we would want to go? We would want to break a subdocument out. Where do you think we would want to create its own model? Any ideas? I mean, like the whole thing. The whole thing. We would want to do, we would want to create an address, and we would want to say type, object ID, ref, address. If it had a one-to-many relationship, absolutely. If the sub is bigger than the model, I don't think there's a steadfast rule on that. But you could think of, if it's bigger than the model, then which one's the most important. It's kind of a trick question here, because we have been talking about these two pieces of data, right? These two documents, only two collections, but we have more than one collection in here. Right? Oh, no, friends, we're in Star Wars. We have characters, films, planets, starships. What if a character, let's go address. What if a character lived at an address, only one-to-one, right? But also a starship was parked at an address. Only one-to-one. And these are still one-to-one relationship. There's only one starship to one address, and only one address to one starship, and only one character to one address, and one address to one character. All right? So then at that point, instead of coming through and duplicating this entire thing over into starships as well, we could break that out into its own document. So it's really all about understanding what your data is and how you're trying to reference it, and where you're consuming it in other pieces of your data, and then building your models around that. Okay. So I said that it becomes very easy to create these massive, documents that are just like kind of one document to end them all. And Lisa kind of alluded to that in her answer when the sub is bigger than the model, because we can have, subdocuments within subdocuments within subdocuments, etc. So you can say like housing type, and that's got a couple things in it. And then in housing type, it's construction material. And instead of construction material, it's material origin, etc. And we can have these like super deeply nested documents where we probably are, you know, a material origin. That could probably just be the planet, right? And in construction materials, we could have all of the materials have their own document and just reference the material in there. So it's, you know, you just have to understand and learn what you're trying to achieve with your data and how to make it more efficient without repeating yourself over and over and over again. If in construction material was the, you know, was like concrete or something, we don't want to have to type in concrete for every single housing type we have on there. We can just reference the concrete document, right, which has the material origin, which can reference the planet, etc. You know, so it's kind of learning about your data and how you use it and how it's created and how to maximize efficiency with lookup and also with writing it in code, I guess. Are there any questions on this right now? This is kind of an afterthought. You don't have to worry about this for the project. Just understand where and when you should break out some data into its own document. All right, let's break once more. We'll come back and we'll learn about some advanced queries, and then I'll let you go and start working on the project tonight. Let's be back at 34 after the hour. Great. So let's get rid of that. Just to kind of wrap that up, talking about our one-to-one relationship, one address to one character. We can definitely just use an embedded document just like this. We could, if we wanted to, create a schema for this itself and just map that to the schema. But we can just create it just like this. Mongo-II is really friendly with us about how to create schemas and how to really do anything. Once again, a one-to-many, we are going to want to include a reference, right? And this is a one-to-one, or this is a one-to-many, but it is more of a many-to-one, right? So one home-based planet per starship. We can tell exactly what planet it's on. And this is a one-to-many in that the pilots, there's going to be many pilots per starship. So we can reference the character by its object ID. And remember, object ID is a Mongo object ID that we have to import from Mongoose. Okay. And so that's kind of the main topic of tonight is relations and our one-to-one, one-to-many, many-to-many. And remember, this could be many-to-many or many-to-few or few-to-few. This can be one-to-few, etc. We want to make it, you know, there's just trade-offs for everything, right? If we rip all of the, you know, if we cut this down to a few, we're going to have more calls to the database. But if we, you know, in the case of the New York City residents, if we have one call to the database, but that operation is going to take a long time. So you really just have to judge your trade-offs and give and take of what you're looking for. Cool. So the last thing I want to talk about tonight is kind of some advanced querying and how to query by not only by the fields that we have on here, but how to do things like sorting, how to do things like filtering, how to bring in dynamic data from our endpoint and create, get exactly what we have asked for using query strings, right? So I'm just going to kind of, on server here, I am going to put it down here, server.get. I'm going to do a server.get, and I'm going to say PI slash, we're going to go starships, no characters. And then we're going to, that's it. We're going to give a rec and a res. And we're going to look for, say we have a query string in here. Remember, a query string is something like it's going to be API slash characters, and it's going to say that, and it's going to be gender. We haven't given a repo link yet, David. We will in just a moment. But say we have something like that. That's our query string, right? And so we know that we can get access to it by using, we can say gender rec.query. So query is going to be that object that has all of these query strings. And right, we can do a lot of query strings in here. We can say and height equals 160. So our query is going to be gender is the key, female is a string of the value, height is the key, 160 is the value. And that's going to be contained on query. So how would we go through, and we want to find all characters that match these ideas, right? And this could be male, this could be undefined, this could be whatever we want it to be, right? This could be any height we want. We want to be able to go in and find all the characters that match that. So let me preface this by saying that there are a lot of ways to do this. And there are, well, not a lot, but there's probably 4 different ways of doing this, maybe more. And that's kind of the Mongo-II way, is that there are a lot of developers out there that are very used to developing in a very specific way. And Mongo-II, and there's a couple of different ways of doing things. You know, say you come from a SQL background or relational database background, and you're used to using, you know, very specific lines of code and very specific commands to get exactly what you want. Mongo-II was like, we want to be super friendly, and we are going to give everyone the opportunity to use the way they want to do it. So what I'm about to show you is not the only way of doing it. If you find that you're working through this and you're stumped and you're looking through the docs and you find a different way to do the exact same thing and you like it and it works for you, cool, go for it. That's fine. But just knowing that how to do this and knowing where to look is going to help you go a long way. And I'll show you a different way, a couple of different ways to do things for us here. So I'm going to start with filtering. So I'm going to create a query, right? And what does this query do? Anyone have an idea? Can anyone tell me what this query specifically does? Right here on line 33. returns all the documents in the collection, right? All the characters. It's going to return every single character in an array. Find is going to return every character because we haven't given it anything, right? We know find and find by ID, and we can give it a ID of an ID in here if we wanted to, I guess. We can do that, but if we leave find blank, find is just going to give us all of the documents back. So let's do this. We'll just call it query. We're going to save this to a string or to a variable. And remember, it's not going to, this does not equal the array, right, of all the characters. It doesn't equal that yet, because what do we need to do in order to get all the characters back from that? Anyone? There's one thing it's missing. To capture the promise, exactly, Alex. It's a dot then and a dot catch, right? It's going to return a promise, is what this is going to return, and that promise will resolve to the array of characters, but we're not there yet. So we do have a promise, but we also have the ability to chain different methods onto this. The first one I'm going to do is filtering, and it's going to be select. Okay, we're not going to do a select just yet. We're going to do sort. We're going to do sort. So we can say sort, and then we can say, how do we want it to sort by? We can, first of all, give it a string. So we can say sort by, what do we have? Our character model. We have a name on there. So we can say sort by name. And it will sort alphabetically from A to Z every single document by the name. Okay, so let's come into here. Let's go. Sort. We're going to say name 1 because this is essentially what it's doing. And now we see that all of our documents are here sorted by the name. Akbar, Adigalia, Anakin, Arvel, etc. from A to Z, right? And that's exactly what this is doing here. So it's going to give us back all of our documents from A to Z. We can also sort in descending order by just putting a little negative in front of that. Okay? In this case, we're going to say -1. And now we see that it starts from the very last, Zam, Yoda, and it goes all the way up to the very first. And we only have 1 through 20 being displayed here. Okay? So that's -1, and that's negative name. We can also very well include that style. Remember, I said that there's more than one way to do this. So that's going to be ascending or descending. It should be the opposite, but it's alphabetical, so it's going to go from A to B, A to Z. And then this -1 is going to start at the bottom and come up. So that would be ascending, I guess. Okay. That's sort. And we can also sort by multiples. Right? So we can say name, sort by name first. And then if you have same names in there, we can say then sort by gender, I guess. Okay. So then if we just had this and we had, let's go. which of these two, if we had this specifically, which of these two characters would be first? That's a question for you guys. Yeah, character 2, right? Because Anakin, so it's sorted by the name, and then we're going to sort by gender, and it goes by alphabetical order again, female to male. If we had this, this would be the order they came in, okay? We can also name right? And so now this character 1 would be first on here. Okay, so we can sort by what we want on here. The next one I'll talk about is filter. And when we filter, we're not filtering the oh, sorry, not filter, select. Excuse me. This is actually a filter. It's select. So this is not filtering the actual documents, it's filtering what's returned in these fields. So we can say we want all of our characters, but we only want the name and the height back. So we can say name and height. And that's going to give us all of our documents with name, height, and it will include the ID. It's always going to include the ID. Okay? So let me see if we have a select on here. Do not have specific select on here, but we would get an object with the ID, the name, and the height on it back. And everything else would not be there. Nothing else would be there. Okay? Once again, we can do it the same way we did sort. And we can say name 1, height 1, comma separated, of course. If we, for some reason, didn't want our ID, right? So this is the way to remove fields when we get them back is just to not include them in our select, right? Or if we don't only want to just remove a field, we can just say select. I don't want to see these two fields in there. So I can say -1 on both of them. And that's the only way to get rid of your ID is to say -1. It's always going to assume that you want your ID, and it's always going to include it, even if it's not in the list of selected fields. ID is always returned unless you specifically give it a -1. All right. And one more thing is that we still need to do our then cars, and now we have just to our characters, right? We still need to do our dot then on here. And I'll show you, we can take and we can chain, right? So it'll sort by the name and the gender, and then it'll remove the name, height, and ID from it. And then we can dot that on it. So we can chain these methods together, okay? One last thing I want to show you is I just want to clean this up a little bit, is our method .where. And .where is going to do some filtering of the documents themselves. Okay, so if we had, let's come back to our agenda, and we only wanted to find the characters that were that specific gender, we can do that. and it will filter the documents. So select filters the fields on the documents, and .where filters the documents themselves. So if I had this, it would only bring the, it would only show us the characters that matched that gender that was given to us in our query string, right? Which is, in this case, female, it could be male, could be anything, right? And that's how we deal with dynamic data like that. So let's go through and actually create something that does this. So we have our query. We have, could possibly have a gender. We could possibly have a height. You know, we could have a lot of different things on here. But we have our query here. And how would, this is not, we'll say that gender is not, gender or height are not requirements. They're not requirements of our API to get the characters. So if you didn't include that, it would just give you back all the characters, right? But if you did, we'll just go with 1 for right now. It would allow us to filter. So anytime you're on a website, or especially e-commerce sites do this a lot, look up in your address bar and you'll see a lot of query strings up there based on items that you've selected on the screen to filter by. That's what query strings are really good for, is filtering. So let's just say if gender, so we'll say not undefined, because for some reason it's 0 or something, that would come up wrong. If gender is not undefined, let's say our query is where gender, and then we can .then and return it. Or we could just query.then and return it like that. So say we only had one object, one possible query behavior, and this is how we would do it. We would check to see if it was even included. We've grabbed that base query, right, characters.find, and we can then say, we can chain it on .where the gender is equal to the gender that user supplied. And what if it was like that? Then it would come back nothing. We'd be like, oh, that's not an applicable gender. And then we could say .then, and inside of our then, something like that, right? Or like that, right? So we can bring these in, and if we wanted them sorted by name, we could say .sort name. Okay, so we can chain a lot of these. They would need catches as well, absolutely. I'm just trying to be a little quicker on it. So you would need catches, and so you would probably, you know, break these out into a little bit nicer. Oh, what happened there? There. Res.send status 500. Okay. Yeah, so that's how you would bring in dynamic data from a query string and allow us to query our database based on that data brought in. And this is essentially going to be a big part of what you are doing this week, is querying our database based on dynamic data. Are there any questions on this right now? There are a ton of different querying methods. We have, I want to introduce you to 2 more because you are going to be using them. is .gte and .lte. Okay. GTE is greater than or equal to. LTE is less than or equal to. And there's a GT and an LT as well, right? So say we also wanted, we had a height in here. And we wanted to make sure that it was greater than or equal to the height. So we could say height, and we could, and we'll take LTE out. We want it to be greater than or equal to the height supplied to us. And this, could be 15 queries long. And so I'll give you a link to a bunch of Mongoose queries, and they map directly to Mongo queries that you can type into your Mongo shell. But this is what you're going to be using tonight and tomorrow and Wednesday and Thursday. Are there any questions on how this works right here? So you could probably do something like this. And then come down in here, and then do another if. I believe you might be able to just chain them as well. So you might be able to just give it query.where, and then if height, let me get back to you on that. I believe this is the method you do it in, but I will get back to you on that. And then at the end, we'll query.then. Okay. Any other questions right now? We'll just remove that. Yeah, you could absolutely do that, Alex. But what if gender wasn't there? And so you would get find gender, and what would it be? What if there was no gender query string in there? It'd be undefined. And so it would try to find every gender that had the gender of undefined, and it would bring back not what you were looking for, right? It would probably bring back null or an empty array, because there would probably, unless gender was required, see, it looks like all of them have gender on here. We didn't necessarily require it in ours, but it would just bring you back all of them that had gender of undefined, when you may have just wanted all of them in general. So that's why we use .where. Where is kind of our, is the inside of find, and we can dynamically use it. And like I said, there are a lot of different ways to do this. And you can chain them all inside of this one where. You can do something like this. It's really, that's the same exact thing as this is right here. But you have to use that $sign because that's a Mongo command. Yep. Well, Alex, you said if you're already checking if gender is undefined, put the query in there. But what if we want to still return all of the characters based on the query string? So if there is no gender and there is no height, we still want to return all of the characters. If we just put that query in there, then that's not going to do that for us. This allows us to create one query and then use it in different ways throughout our code. Like I said, there's many different ways of doing it. If you find that a way that you like using more and it works well and it works for you, go for it. Don't worry about this part, but just know that something like this does exist. And if you find out, if you go reading through the docs and you're like, oh, that works, that's cool, that's not wrong. So keep that in mind. There's a lot of different ways of doing all this stuff. Awesome. I am going to break now if there are no questions and have you all work on the project this week. This week is going to be another solo week just because you started Mongo last week solo. We'll have you continue working through this week solo, and we'll go back to our pairs next week. But Greg has your... There it is. That is your repo. Please fork, clone, and work on that solo this week. If you have any questions, I'll be here the rest of the night, and so will Greg and Frank. Have a good night, everyone, and we'll see you tomorrow.